Welcome, my friends! In this video, we will discuss one method of displaying quantitative data called the stem and leaf display. You may be familiar with a histogram, which plots classes or groups of a quantitative variable on the horizontal axis with frequency on the vertical axis. Making a histogram is one of the most common ways to visualize the distribution of a dataset, that is, how frequently different values of the variable occur. One complaint you might have is that in a histogram, you lose the specific data values. For example, this bar includes presidents who had either 3, 4, or 5 children, the whole numbers between 2.5 and 5.5. What we don't know from the histogram is how many presidents had exactly 3, exactly 4, or exactly 5 children. All we know is that the combined total in this range is 17. A stem and leaf display, as we'll see shortly, allows us to visualize the distribution of a quantitative variable without losing any of the information in the data. The easiest way to show you how to make a stem and leaf display is to simply work through an example. Here are the first exam scores for one of my IntroStat classes, which contain 25 students. The first thing you'll want to do is identify the minimum and maximum data point. That will help us know how to organize our stem and leaf display. In this case, the smallest value is 38, and the largest value is 103. That means my data set starts in the 30s and then increases through the 40s, 50s, 60s, all the way up until the 100s. I'm going to let my stem represent each base of 10, so I'll have 3, which will represent the 30s, 4, that will represent the 40s, all the way until 10, which will represent the 100s. Now I simply draw a vertical line and start listing the ones position values on the right side of the line. Our first observation is 38, so we put an 8 on the right side of the vertical line next to the 3. The value to the left of the line is what is called the stem, and the value to the right is what we call the leaf. Next, we have 41, so we write a 1 next to the 4. Then we have 2 9s for the 2 49s, a 3 next to the 5 for 53, etc., until we have recorded every value in our entire data set. Here's what the completed stem and leaf display looks like. We are just missing one small but very important part, which is what is called the key. The key tells you how to read the stem and leaf display. The most common way to express the key is to just list an observation and explain what it means. So you might see something like this. 3, vertical line 8, represents a score of 38. Now that we have completed the stem and leaf display, we can use it to make some observations about the data. It appears a large number of students received a score somewhere in the 90s, with the most common score being a 98, which occurred 4 times. If we look at the display on its side, it will look similar to a skewed left histogram. In fact, here's what the histogram from this dataset would look like. It's very similar in shape to our stem and leaf display if we rotate it by 90 degrees. What I have shown you is the most basic stem and leaf display, but there are ways to modify the display slightly to accommodate the data that you are analyzing. For example, a stem and leaf display can be used to represent data with decimal places. Here we have the 100-meter dash times of several high school students in a gym class in seconds. We can let the stem represent the first 2 digits of their time, and the leaf represent the first digit after the decimal, what we call the tenths place. Our key might look something like this. 15, line 3, represents a time of 15.3 seconds. We could start listing our stems, which would represent the numbers before the decimal point. 12, 13, 14, 15, and 16. But then we notice we have a large gap until we get to the next observation, which is in the 26s. We can use the changing scale symbol to represent that we are skipping over some values, and then continue with 26 and 27. Finally, we can fill in all of the leaves, which represent the decimal places. 12.2, 12.5, 12.5, 12.9, and we can continue this process until we have completed our stem and leaf display. Another issue you can come across is a dataset that has a very large number of observations for a particular stem. In that case, it might be beneficial to split the stems so that they each cover 2 rows. For example, Here are 20 speeds in miles per hour recorded by a police officer on a freeway that has a 70-mile-an-hour speed limit. There are so many speeds in the 70s that the leaves for the 70s stem would be off the page if we created a traditional stem and leaf plot. The solution is to split the stems. Typically, a stem is split so that the ones place values 0 through 4 are listed on the first line, and the ones place values 5 through 9 are listed on the second line. Here is what the rest of our stem and leaf display would look like with the split stems. The observations ranging from 70 to 74 are listed on the first 70 stem, and the observations ranging from 75 to 79 are listed on the second 70 stem. Traditionally, if you split one stem, all of the stems that can be split will be split for your dataset. So you can see here that the 60s are also split. The observations from 60 to 64 are listed on the first 60 stem, and the observations ranging from 65 to 69 are listed on the second 60 stem. It doesn't make sense to split the 50 stem, as there would be no observations in the 50 to 54 stem. It also doesn't make sense to split the 80 stem, as there would be no observations in the 85 to 89 stem. The final variation on the stem and leaf display we will discuss is what is called the back-to-back stem and leaf display. This option should be used when you want to create and compare the stem and leaf displays for the same variable collected from two different populations. An example might be comparing the first test scores of students in an intro stat class at both Grand Valley State University and at Grand Rapids Community College. In this case, there will be stems which will have leaves to the left representing GRCC students and leaves to the right representing GVSU students. So our key might look something like this. 6, line 7, line 3 means that there is a student who scored a 76 at GRCC and a student who scored a 73 at GVSU. We read from the middle to the left or from the middle to the right in a back-to-back stem and leaf display. Here is what the completed back-to-back stem and leaf display would look like. Notice how the stems are in the middle and the leaves are either to the left for GRCC or to the right for GVSU. So we have 38, which is our first score for GVSU, 46, which is our first score for GRCC, 41, 49, and 49, which are all GVSU scores, etc. We can see that the distribution of scores is a little bit more symmetrical for GRCC students than it is for GVSU students, if we view each display as a histogram on its side. In fact, here's what the histogram looks like for the GRCC students next to the rotated stem and leaf display. They have a very similar shape. Here are the side-by-side histograms for the GRCC and GVSU test scores, which tell us the same story. The GRCC scores are approximately normal or mound-shaped symmetric, and the GVSU scores are a little bit more skewed left. Alright my friends, that wraps up our discussion of stem and leaf displays. We will be exploring many more fun and exciting statistical topics that you won't want to miss, so make sure to check out our other videos.